Today we're going to look at how to apply trigonometric ratios and formulas, and some of the things that you want you to be able to do after this lesson is to draw on some facts about right angle triangles. You know, the trig ratios like SOHCAHTOA, and using Pythagoras' theorem to determine sides of the triangles, and we're going to use those trig facts, those triangle facts, to come up with more information to each question we're going to look at, and we'll see how it all pieces together nicely to be able to answer what we're after. And also you need to be able to pick the right most appropriate formula to simplify an expression or evaluate an expression. Okay, so first off, we're going to review what we looked at last lesson on how we can get more information from our trigonometric expression about a right angle triangle. So let's have a look. First off, here's all our formulas that we had drawn on. As you can see, we've developed quite a few. We've got sum of angles, we've got a subtraction of angles. For sine, cos and tan, we've got what our double angle formula set, 2 times an angle, and from the cos to theta formulas, we came up with these nice half angle formulas. Okay, let's see how they go together. So last lesson we drew on the fact that, well, if we know something like sine of theta is equal to some amount, then relating that to trig ratio, sine of theta equals opposite over adjacent, okay, to the sides of a right angle triangle, then what else can we determine about theta, about angle? Okay, so first off, angle theta is, we've told here in the domain, it's between pi and 3 pi on 2, so that quadrant is the third quadrant. Okay, and you've got to remind yourself, well, what do we know about the third quadrant? Well, sine is negative and cos is negative, but tan is going to be positive. So first, let's think about the equivalent first quadrant angle of theta. Since all angles are symmetrical in your unit circle, you've got equivalent angles in all 4 quadrants. So let's draw on the fact that, hang on, this theta, even though it's in the third quadrant, what is its equivalent first angle quadrant, which makes it a little small acute angle? And let's look at the right angle triangle geometry we get. So sine, cos and tan are all going to be positive, and so we can see from the fact sine of theta of the small angle theta is an opposite over hypotenuse, so that's the sides of the triangle there, and from that last lesson we looked at, hey, we can just get the adjacent side of the triangle using a bit of Pythagoras' theorem. So in this case, this is 4. So using the adjacent side of the triangle with the hypotenuse, I can come up with an expression for cos of the angle. Now, I have to make a connection. Hang on, the angle that I'm really interested in is not just the first quadrant angle, but the angle that is between pi and 3 pi on 2. That's the third quadrant angle. So what is the sine plus or minus of cos in the third quadrant? Yep, it is negative in the third quadrant. So I must make sure I check what is the sign of sine, cos and tan in each quadrant that I'm going to be in. And I can also express tan. Tan is opposite over adjacent, so an opposite of 3 divided an adjacent of 4. What else could I say? Well, sec. Sec is just the reciprocal of cos, so it's negative 5 on 4. Cosec and cot, I can come up with all those reciprocal function values just by taking the reciprocal. And then I could even apply a formula and come up with something completely else, like sine of twice the angle. Using the formula, there it is, 2 sine theta cos theta. I've got values for them, so I plug them in. There's 2 of negative 3/5 and negative 4/5, and I get 24 on 5 for my value for 2 sine theta. Okay, cos half angle. You can even draw on a different formula, like a half angle formula. And there it is, there's the half angle formula, square root of 1 plus cos theta on 2. And I know what cos theta is, that's this value here, so I can just do a substitution. Sub it in, there we go, and simplify. And that's simply root 10 on 10 as my value. So, works out nicely. Now, the half angle formula, I have to remember, because I've done the square root, I've got plus and minus in front of the square root. So what's it going to be? Is it going to be the positive or the negative value that we have here? Well, this is where you come back to your unit circle and see, well, that theta is an angle between pi and 3 pi on 2. That's your third quadrant. Cos is negative in the third quadrant. Okay? So we must have it lying properly in the third quadrant. But you have to keep in mind, this is where theta is. Theta is in the third quadrant. What's our angle we have here? It's not just theta, it's half theta. So since theta is between pi and 3 pi and 2, what is half theta in between? Have a look. Half theta is in between pi on 2 and 3 pi on 4. When I half the angle, I've changed quadrants. I'm now in the second quadrant. Okay, so that's very important to remember there. Changing quadrants, I'm in the second quadrant. Luckily, cos is still negative in that second quadrant. It's not the same as angle theta that I got to remind myself. I got to check about what is this angle inside the bracket of my circular functions at each point. Alright, very good. Let's keep going. Let's learn about something new. Well, we looked at the situation of how to draw on triangle facts from one piece of information about an angle. What about if you've got two angles and two pieces of information? Then what else can we evaluate? Say cos of twice some angle alpha or tan of alpha plus beta. Interesting. So first off, we want to know about our trig ratios, our triangle facts. So draw a little triangle representing this information here. Sine of the angle is some opposite side divided hypotenuse. So my little triangle has to have an opposite side to the angle with a hypotenuse of 5. And using Pythagoras' theorem, I see that the adjacent is 4. And I can do the same with my other angle over here, angle beta. Well, this is opposite of 24 over a hypotenuse of 25. There it is. Using Pythagoras' theorem, 25 squared, take 24 squared. Gives me square root of 49, which is 7. Very good. Now, so we're told specifically what we have here. Our angles, alpha and beta, are really angles between pi on 2 and pi. That is in the second quadrant. So to get the values, we drew on first quadrant equivalent angle, some angles that are in the first quadrant. Now, we have to now take into consideration the positive or the negative of my sine, cos, or tan that relate to these triangles for these particular angles. So, there you go, second quadrant angles. So, sine is positive, but all the others, and you can see the sine values, sine of the angles there are positive, sine of this angle is positive, but cos of the angle is the opposite over the hypotenuse, and it needs to be negative because cos is negative in the second quadrant. And cos of beta, well, it's the adjacent side, 7 over the hypotenuse, 25, but negative because it's in the second quadrant. Now, let's draw on those new triangle facts and make a connection to our rule. Cos of twice the angle. Well, that's my double angle formula for cos. So I can look that up and write it down here. There it is. Cos squared alpha, take sine squared alpha. I have those values now. I've worked them out. So I substitute them in. and I can simplify nicely. There we go, 7 over 25. Okay, and just to check, pi on alpha is in the second quadrant, and so we must have twice the angle. We got to check what is the angle. We've got twice the angle. If alpha, half of the angle is in the second quadrant, twice the angle must be in pi, between pi and 2 pi. So that's both. That's the second quadrant and the third quadrant. Or I should say, hang on, no, my mistake. It's the third quadrant and the fourth quadrant. Okay, so given that, we have to conclude, well, having those two angles, it could be plus or minus, couldn't it? Well, which one could it be? Well, if we do a quick check on the calculator, from our original triangle fact here, I've got, I could check on the calculator. I can do what's called the inverse sine to check what is actual the size of alpha. So the inverse sine of 3/5 is 36.9. But that's what the calculator gives me. But that's a first angle. That's a first quadrant angle. I need to get it in the second quadrant. So to find that, I have to subtract that away from 180 degrees, and that puts it in the second quadrant. That's 143 in the second quadrant. Okay, so you got to do that little correction. Now, if I do a cos of 2 lots of 143 degrees, there it is, I get exactly 7 out of 25, and that's what I've worked out there, and it'll be a positive. Okay, so not bad, it works out nicely. Tick. Let's try the next one. So to work on this one, what I need to do is first make a connection with tan of plussing two angles together. So that formula is, looking up my formula sheet, there it is, tan of alpha plus tan of beta divide 1 minus tan alpha times tan beta. And I can come back to my triangle ratios, my trig ratios, and let's work out what tan should be. So tan is the opposite divided by the adjacent side, 4 on 3. Okay, and alpha is an angle in the second quadrant, and in the second quadrant only sine is positive, so that means tan is negative, so make sure you put a negative sign there. What about tan of beta? So tan of beta, again, there we go, opposite over the adjacent, so 24 on 7, and beta is in the second quadrant, sine is positive, so that means tan must be negative, so make sure you put a negative in front of your value. Okay, so now I've got my values, I'm going to substitute them into my formula. Alright, now make sure you use brackets appropriately, because we've got negatives multiplied by negatives, and we got to deal with that carefully. Adding fractions or subtracting fractions, make sure you get a common denominator. In this case, common denominator between 4 and a 7 is a 28. Same in your denominator here. Get this, simplify this fraction. You've got to do a lot of fraction work here, so be careful. Think back to primary school. And this division of fractions, I can do a multiplication of the reciprocal, and that's going to cancel out the 28. So I get positive 117 on 44. There's your value. Fantastic. Well, interesting use of what to do with having two triangle facts. We've got to do 2 lots of trig ratio, looking at the right angle triangle, and working out all the important facts that we need to substitute into the formula. Let's look at another problem. This type is going to involve the use of solving simultaneous equations. Now this is going to be quite interesting. So, two methods for solving simultaneous equations is a substitution method or elimination method. For this problem we're going to be solving using an elimination method. Okay. So, first off, there's our two angles, angle A and angle B. There's a fact about angle A, cos of A is 7 on 8. Now, here's a fact about both angle A and angle B together. And we've got an addition of angles, gives us a third. Now, from that, we're told angle A and angle B, well, they're just acute angles in the first quadrant from 0 to pi and 2, so they're all positive. Sine is positive, cos is positive, tan will be positive. And our job is to find the exact value of sine of 2b, drawing on the fact of cos of A and sine of A plus B. Interesting. So let's set up our trig ratios and drawing on facts from our right angle triangle. So set up a triangle just for angle A having a adjacent side of 7 and a hypotenuse of 8. There it is, and we can use Pythagoras' theorem to work out the opposite side, root 15. So from that we can get sine of A, opposite over hypotenuse, root 15 on 8. Okay, now check, quick unit circle check. First quadrant, so that must be positive, which is important. Make sure you go through that process to ensure you get a positive value there. Okay, let's draw on the triangle facts from the second piece of information. So this time, let's assume that angle A and angle B are quite small, all small, and when they add together, they're still small and within the first quadrant. So we get hypotenuse of 3 with a opposite side of 1, and so we can use Pythagoras' theorem to work out the adjacent side, root 8, which is 2 root 2. So we did that on the assumption that A plus B together is still an acute angle and between 0 to pi on 2. For now, that's the best assumption to make. So therefore, we can say something about cos of this addition of angles A plus B, using the adjacent side, 2 root 2, on the hypotenuse, 3. And there's the value for cos of that angle. Okay. Now, we need to make a connection now between sine of angle A plus B and what we know about that in terms of a formula, because inside the formula we've got lots of other angles. We've got cos of A and we've got cos of B and sine of A and sine of B. So there's the full formula when it's expanded. Sine A cos B plus cos A sine B will equal to a third. Now if you look at that, we know some of those parts, but we don't know all of those parts. So I've underlined in green cos B and sine B. We don't know anything about that. They are still unknown. But let's substitute into sine of A the value which we got here. There it is. Sine of A is root 15 on 8. And we know something about cos of A. Well, that's given to us in the question. 7 on 8. Let's substitute that in. And here's our first equation. This equation has two unknowns, cos of B and sine of B. Now, let's do the same process, but with cos of A plus B is equal to 2 root 2. Well, let's expand cos of A plus B using the formula. There it is, cos A sine B minus sine A cos B will equal to 2 root 2 on 3. Let's substitute what we know about the parts. Cos A we know, sine A we know, but again, sine B we don't know, that's unknown. And cos B we don't know, that's unknown. So that gives us our second formula. So we've set up, using our addition formula, two equations in terms of two unknowns. So the next job is identifying the unknown parts in the equation. We're going to solve the two equations simultaneously. Remember doing simultaneous equations? We've got the elimination method or a substitution method. So there's your two equations. Now, we've got our two unknowns. Let's relabel them. So let's call cos of B, angle B, let's call that x as a different variable. Whereas the other unknown, sine of B, let's call that y. So it gives us two linear equations that we can solve. So let's solve them by adding them together. So by doing so, we're eliminating the x. This is a positive root 15 on 8, while this is a negative root 15 8 times x. So adding them together will eliminate the x. So we've got the y's, add the y two parts together, it gives us a 14 on 8y is a third plus 2 root 2 on 3. There it is. And now let's solve for y. Multiply by 8, divide by 14. And we will have the fraction over 21, and it will simplify down to. Okay, so that's a simple surd as we have it, and therefore we know what exact value is for sine of angle B as this surd. Well, let's keep going with solving the equation. Let's take y and let's substitute that back into equation 1 and solve for x. So we do the substitution, we have to expand this part. And we can simplify it down, cancelling out common factors first. Make sure common factors in both terms in the numerator, cancels out with a factor in your denominator here. And subtract that surd over to the right hand side and simplify. There it is. So subtract your fractions. And then finally, we've got this here, we've got to multiply by 8 and divide by square root 15. Simplify a little bit more. And there it is, there's our surd in the most simple form. So this kind of work, you just go very careful, simplifying your surds as you go. Alright, so therefore we've got an exact answer for cos of angle B. Now finally, let's look at the whole purpose of the question. We had to work out an exact answer for sine of 2b. So we're going to draw on all the values we've determined now and apply the formula to evaluate sine of a double angle. There it is. There's the formula for the double angle for sine. So sine of 2b is, we substitute what we know for sine of sine of b and cos of b. And we evaluate. Carefully we can multiply things out. That's a difference of 2 squares, so we'll end up with a 4 squared, subtract, and then the square of an 8 root 2. Okay, so if you go through that carefully, you'll get the hang of it. 16 take something like 128, and then you divide by the denominator here of 63 times root 15. It'll all simplify down nicely and will give you this surd. Ha, what a challenging problem, but it's a very important one and something to practice and study. Now, one more to finish it off. This is a nice easy one. Here's an odd angle, cos of 75 degrees. We're not used to working with 75 degrees, so let's see what we can change that to. First off, let's use complementary angles. How does cos and sine relate? Well, cos of 90 degrees subtract 15. Well, that's really how we can represent 75 degrees. Subtraction away from 90 degrees. Well, if you express that in radians, you've got 15 degrees, which is pi on 12, and we're taking that away from a pi on 2. So if you look at your complementary angle rules, you'd realize, well, subtraction from 90 degrees, well, that turns the cos into sine of the small angle, and it's going to be positive. So sine of pi on 12 really is sine of pi on 6 and a half. So voila, there you go, there's a half angle. Got to draw in a half angle formula. There's the half angle formula for sine, where the small angle we're going to have is pi on 6. So substitute pi on 6 in there for theta, and we can evaluate. Voila, look at that. Simplify your surd and you get this as your simple surd result. So it's amazing stuff we can do with trig. And our job now is to draw on what we learnt in this video. Maybe you need to re-watch it again. And we're going to work on some of these great exercises. So well done everyone. Keep studying.